Hello, everyone. Thank you for joining us yet again after a brief hiatus where we weren't around for last month's show and on a little bit of a different hour today. Um, but we're here, as always, on Langdon White. I'm a professor at Boston University. I used to be a Red Hat employee. And I've been involved in containery stuff since about 2012. I'm a big fan, and also realized very quickly once I started using it all the time that orchestration becomes really, really important. And so that's kind of what brought me to Kubernetes. And then the other thing, as I often mention about this show, the reason for this show is because when you're talking about an open source project, it's really important to maybe talk to the people who are actually kind of on the inside. Because when you talk to product managers or look at press releases or whatever, that may or may not be the most interesting things that are going on in the project. Because if an engineer really wants to get something in, they can do it on the weekend and still contribute it. You don't have to, it's not proprietary software, so things are kind of open ended. And I'm joined today by Chris Porter, who is his title. It says something along the lines of Director of Solutions at Red Hat for StackRox. But as I often say with Red Hat, I'm going to let you introduce yourself because you never know, and they change all the time.
Thank you. Yeah, Chris Porter here. I am a solutions architecture. That's what we do. I'm an advisor to clients, to customers of Red Hat. But I'm a specialist here on the subject of container security, Kubernetes security at Red Hat. I interact directly with our customers. You may see me on other events and see me working with the teams for things like trade shows, Red Hat Summit coming up next week. I have a background in security. I came to Red Hat when Red Hat acquired the company that I was working for, this StackRox container security company. So I've been spending about 25 years now actually doing security for a variety of startups, some names you'd recognize, and still continuing that today.
That's really cool. I come from the developer background of, I'm very impressed with myself that now I most of the time leave SE Linux on, I most of the time leave my firewall on, but I do remember the old days of the only way you could figure out what was going on was basically cracking everything open.
That's right.
So why, so in the context, I mean, part of the promise of the containers, right, is that security is kind of less difficult or something. Can you give a little bit of explanation of what do you mean by container security? Like, what is different about that versus, I don't know, VM security or something?
That's a great question. And it's a big topic. I think that there's an opportunity for better security, for easier security with containers. Containers represent a form of a constrained runtime, right? You think about a container and a lot of folks think, well, I can get a shell into that container. I can look around the file system. I can run commands, or I might start up a container that has a bunch of utilities in it, programs. I might run them as a cron job. They're really useful. But if you think about them as just like lightweight virtual machines, you're getting the wrong impression about them. That analogy only goes so far, right? They don't have their own kernel. They're just processes running on the node, on the container runtime that you're using. Each individual container really doesn't do all that much. Like, part of the promise here is about breaking up the workload of a complex application into microservices. And then each of those individual components is very narrow in what it does. So in many ways, that can make security easier, right? We can restrict that container down to what it should be doing. That idea of, hey, you're only doing one thing, let's limit you to one thing. That's actually something that's practical in a container context that would not be practical to do for a general purpose virtual machine, right? We expect a Linux server to do a whole bunch of different things, and for users to log into them, we expect those servers to live around, for a long time, even if we're treating them as cattle, right? They do have a longer lifespan, whereas containers could last, minutes, hours, right? We're constantly replacing them. Go ahead.
Yeah, I was just going to say, actually, I mean, in fact, right, before kind of containers really took off with .cloud, right, people were, and even today, right, people were increasingly trying to dedicate a VM to almost like a single process, right? The problem is you had, like both from a security and then also kind of performance perspective, you have all this other stuff going on, right? That you either
That's
have to
right.
secure because, it has a bunch of other potential ports, right? Or somebody wants to just do this one thing, and then somebody just logs into the machine. There's all these things where, the VM kind of like inherently wants to be less secure in a sense.
That's
Um, and the
that's right.
container is a little more protected. So I strongly agree. Like I'm a huge container fan, as I said before, and I think that's kind of one of the interesting aspects. And I think it's kind of one of the things that I would point out, and maybe you can comment on as well, is like there's kind of two sides to that container security, right? There's the inside of the container, right? But then there's also the outside. Where does kind of the security tool chain or whatever that you work with Red Hat or at StackRox or whatever, which part of that problem are you mostly working on
So
or
we
providing?
work on both because they're both important, right? So we talk a little bit about, to steal some of the cloud providers' security messaging, right? There's security of the cluster and there's security in the cluster. And so both are important, right? If you are, maybe you're a viewer who has a home lab, right? You just want to make sure those virtual machines are set up in a way that you're keeping them patched and updated, your Kubernetes version up to date. You want the cluster to be secure itself, right? Running any kind of application platform that has an API, that has authentication, like those are potential risk factors, right? If you're exposing those endpoints through, through an ingress controller, again, you've got a potential exposed point. And Kubernetes itself and the container runtime, we see bugs, we see vulnerabilities in those, and keeping them up to date is a critical part of that. So we see that that's a big function, and a lot of security teams often set the responsibility. So a large enterprise or a large organization, you'd set the responsibility of that to typically the platform teams that manage those platforms. Personally, I like to see folks that are doing this in an automated way, right? That updates happen as a matter of course. If you're using one of the big cloud provider Kubernetes platforms, then you should be understanding that in the security responsibility shared model that they have, that you are responsible for doing things like updating the version of Kubernetes that you're using. And in many cases, you're also responsible for updating the node of the worker operating systems as well, right? So only a portion of that job is done for you, and you're responsible for the rest of it. So that the division between your responsibility and the cloud provider responsibility kind of varies a little bit depending on the model that you're using. Within the container runtime, one of the best things about this is really that containers and Kubernetes really align well with DevSecOps, right? So when you think about DevOps and you think about everything as code, right? Infrastructure as code, dependencies as code. And we also want to think about security as code. And so, and DevOps involves a lot of automation, right? We don't want human mistakes. We want repeatability. And so when we think about security, we want it to be embedded in the code, right? And so that really lends itself well to containers, right? Which are effectively defined in code. So if you have to fix something like patch a vulnerability in your image, what we want to do is go back to the Docker file. We want to go back and rebuild that and import a new version or a fixed version of that particular dependency, rebuild and redeploy. Now you can do that with VMs, right? With tools that build VMs, from source code like that. But it really works better, quicker, around containers and Kubernetes. And if you are adopting like a, truly continuous deployment environment, right? You can make those changes very rapidly and not interrupt anything because Kubernetes, obviously, the orchestrator can help you keep things running while you're replacing a pod, right? Using auto scaling and stage rollouts, things like that. So we really think that automation, that speed of time from discovering an issue to the resolution of it, again, better security than you would likely be able to get in a traditional application environment. So,
Right, right. No, that makes sense. And I think, the other part of it too, my old joke about, developers don't care about security, kind of the more you can also put that kind of into your infrastructure or into the code or, whatever that exactly means. the less need you have for like every single person to be deeply familiar with, the ingress and egress policies of the, overall Kubernetes cluster, right? Or things like
Right.
that. And so I think that also makes a huge difference. So I kind of jumped right into talking about containers, but I wanted to ask you, we typically ask on the show is like, what brought you to open source in the first place? What, where, was it accidental, or did you get involved in an open source project because you had an itch to scratch?
So my involvement, unfortunately, comes out of frustration with commercial software, right? That there's a lot of good commercial software out there that you can buy, and over the years I've used quite a bit of it. And you get frustrated with the limitations of it, and you're like, boy, if I could just tweak this one thing, right? This one setting, this would work better with my workflow. Early in my career, I was working for media design companies. I worked for a huge Unix company, and our software was proprietary, but a lot of it, all the source code was available internally, and it was easy to contribute there. And that lent itself to to contributing externally. I got involved in a couple of projects. Most I think at this point are obsolete. And then at the commercial companies that I've worked for, I've always been a contributor to the source code projects, whether it's QA and tests and things like that. Like, I've not been a software engineer on StackRox, for example, but I have contributed code, testing, and then things that I call glue code. Glue is the scripts and the integrations and the examples that our customers need to make the software effective in their environment. No tools, especially in security, no tools work in a vacuum, right? I've got to
Mhm.
integrate security events into a dozen other systems that my customers might have, and so building the examples and the glue based on standards and protocols is a lot of what I do today, and that's all open source, right? Thankfully,
Right.
the standards are open source, right? The specs, the sample implementations, that makes my job a lot easier for getting these things done. And the thing that drives me nuts is commercial solutions that don't have that kind of open documentation or open source examples. Makes it very difficult to do things like just integrate the two products together that our customers need to make them effective.
Right, right. Yeah, I often argue actually to students. It's like you're building it wrong if the vast majority of your code isn't glue code, right? Like,
Right.
you these days you should be using significant amounts of APIs and and pieces of work from various sources, and that's how you actually build an effective application these days. And so, yeah, I've always done glue code, except not always just to fit products together, but also like that's where that business value add is, right?
Yeah.
Because I think it's really really important. In fact, it was funny when you said glue code. I hadn't thought about this in a while. There's actually a conference called GlueCon, um, that is about basically APIs and stitching APIs together, which
Yeah.
is I always thought was funny. I think it's still around. But what I was going to ask you, okay, so that was kind of the open source component in the open source, and you spent also a lot of time in kind of software and proprietary scenarios. What do you think? Do you have an experience or a feeling, or I'm not quite sure the right word, but like what changes when you write code for a proprietary software company and versus open source? Is it any different, or is it does one change how you operate?
Well, obviously, I'm thinking about this always from a security perspective. And open source code has a trustworthiness to it because everything's on display. I mean, there's just no doubt about it. So, if a lot of commercial organizations that produce software certainly do follow secure coding practices, right? They scan dependencies, they go through static and dynamic security checks. There's a lot of rigor around that. It's just that it's not on display. And if somebody decided to skip that step today, it's not always clear to the customers that was done. I noted the stark difference here when it comes to a vulnerability, right? The public disclosure of a vulnerability. In Red Hat and in open source projects, when those get reported, it's on display. You can go to GitHub, you can look at the bug report, right? You can see the mailing list where the nature of the vulnerability is being discussed, right? Even if the teams don't disclose it publicly to a CVE number for NVD, that it's there and it's being discussed. with commercial software, you often don't find out about a vulnerability until the patch is released. So suddenly you see a new version of software for, a workstation, even phones and embedded devices. You'll find that there's a new release that fixes a critical security bug that really nobody knew about or nobody, discussed. And that early disclosure is important. There may not be a fix available, but it's important for, security officers to understand the nature of that vulnerability, the risk that it presents, being able to find out, are we impacted by this? Is this software in our environment? And what mitigating steps are there while we wait for a patch? So that I think security especially has benefits for openness that, that transcends almost everything else. How a particular product is developed ultimately depends on how secure it is, what kind of oversight. Now, the open source world isn't perfect, of course. Too many projects don't have enough oversight. There's not the funding. There's not the expertise, right? Developers are not always security engineers. I'm glad to see that there is motion in the industry out there and from government actually in the US to help to improve that situation, because the only cure for open source is more open source, right? More eyeballs makes the problem. I never want to trust a proprietary encryption implementation, for example, right? You want these to be absolutely transparent to everyone because of how easy it is to, to game the system, right? To put backdoors in. So.
Yeah, I mean, I don't know if you were directly alluding to it, right? But the XZ, fiasco from a few weeks ago. I think that's kind of what's so interesting about it. They do, some bugs, right? Obviously, get embargoed for a period of time, and so I don't know if that one was embargoed at all. But I think I just remember, like over the weekend, all of a sudden this whole thread starts blowing up right on my email, and I keep getting notifies that there's, all this discussion, which makes me kind of go, oh, maybe I'll go look at this, right? And then now I, immediately can start, kind of checking my environment to say, oh, am I vulnerable for this? Is this a problem I'm going to have?
That's right.
Luckily for me and a lot of people, right, it was caught when it was in, essentially beta.
Right.
And so,
but we could pull on that thread a little bit. Imagine it wasn't. Imagine it got all the way to a released version, right? Now, at Red Hat, if it had gotten into RHEL, it would have been an investigation. Once the reports came in, maybe it would have been discovered by other engineers, but it was out there. Let's say you are a customer using open source dependencies, right? There's a lot of applications that depend on XZ. It's embedded in a lot of capabilities. So then exactly the question, you discover this threat, it's on the news. How do you respond to that, right? And so this is a pretty horrendous thing, right? It potentially backdoors SSH. It results in the disclosure of credentials, right? Well, the answer is going to be, and this is true of all security, right, would be, being able to quickly answer the question of where is this and where are we impacted, which applications, right? Which, back to containers, it's a little bit easier to inventory that when you have Kubernetes clusters and container images and a private registry. So there's a lot of advantages there. So you can enumerate the places where you're impacted, but it's good old tried and true defense in depth, right? Multiple techniques for securing applications, right? Disclosure of credentials is only possible when software components have some access to the internet, right? And they have to get out and transmit that somewhere. So, having tight control over network egress is important. SSH, well, one of the things that we're seeing with containers is that people don't use SSH, right? But making sure that SSH is access is not provided through simple credentials, right? Making sure the teams are rotating credentials, right? You always have to assume that one of you, if you're, again, a large organization, that one of your insiders is going to be careless, right? I won't say malicious, but probably careless, and they're going to have a disclosure. They'll respond to a phishing email or something. They'll lose a laptop, whatever that might be. And so having a path to, being able to rotate those credentials and eliminate, the risk there. There's a lot of other things that we could talk about like this. And, a mature security organization is going to have that attitude of, we're breached already. Let's assume that we are breached, that right now there's something floating around. There are undiscovered vulnerabilities. There are, some sort of backdoor in software that came from a hardware or software manufacturer. Like, how do we deal with that? how can we put controls in place to make sure that even if such a thing was present today, that we have a plan for addressing it.
Hmm. Yeah, no, that makes a lot of sense. It was while you were talking about it, it brought to mind like when I was doing more kind of boutique consulting or whatever, and I still remember, it was kind of the early days ish of the cloud, and so many organizations were resisting kind of moving things into the cloud because they were like, oh, it's so much less secure because it's not in our data center or whatever. Then we'd essentially run something like an nmap scam against their data center, and discover all the holes that have been poked through somewhere along the way,
That's right.
that everyone has forgotten about because they have to do this batch job or whatever. And one of the things that I also really like about containers is because you have that limitation of what it can do, right? Like, as in,
That's right.
it's only supposed to be doing this small piece of work. You can also put security controls around it that only let it do that small piece of work, which I
That's
think
right.
is significantly harder, in
That,
other kind of methods.
that's right. It's absolutely impractical to do some of these things in a VM context. One of my favorite examples is my recommendation that you should run all of your containers with a read-only root file system, right?
Hmm.
Because a container has essentially this, very ephemeral, very temporary root file system. It looks like a Linux file system. And if you're a developer and you're writing to, var log, and you're expecting that log file to be around somewhere in the future, you're making a mistake. You have a misunderstanding
Yeah,
about
yeah,
containers. But by making that read-only, that file system read-only, right? And I'm not talking about persistent storage, which is allocated in a volume declaration, right? There are a variety of
right,
methods,
right,
but just the slash, right? The root file system mounted that way. You prevent anybody who manages to gain access from doing things like installing a backdoor, right? Persisting themselves, doing whatever to the file system there, or dumping a malware payload to disk and executing it, which is a pretty common attack pattern, right?
right.
I get a remote code exploit going, like the log for shell vulnerability. I run curl, which is another thing that you shouldn't have in your containers, but it's a separate topic. You curl to go and
Yeah,
get some malware and crypto miner or whatever, and you run it. And that attack pattern can be disrupted in a lot of different ways, right? Controlling egress. Don't let curl go out to the public internet. But that writable file system means that I can dump that somewhere on that disk, and it's hell to go and track those things down. If the container is deleted, I lose that forensic evidence. But by making it not possible to write there, then I kind of eliminate a lot of those attack threats right away. And it's practical to do. You
right,
can't do that in
right.
a virtual machine, but you can do it in a container. And like you said, limiting the network, right? What comes in, what comes out. It's possible to enumerate the connections that a given pod in Kubernetes needs. And
Hmm.
it's less practical to do so in a VM. If you know specifically what that container is going to do, the Kubernetes network policies can be written to restrict it. I'm not saying it's easy, but we
Right.
are saying that software developers have a responsibility for the security of the applications that they're writing. And shift left means, a lot of these topics are now becoming part of the software developer conversation. And, the security teams see this as their responsibility, but, we're seeing the division of labor here shift a little bit, where the security team sets the principle, the guardrails, right? A security team might say, don't use a high number or a low number port for networking, right? And then developer sees that requirement and then, just knows that in the Kubernetes YAML, I expose on a port above 1024. So there's still the same implementation, ultimately, the same control is in place. It's a question of who's doing the designing and who's doing the implementing.
Right, right. Actually, I think it makes me have a bunch of thoughts. But one of them was, that's as you were saying, DevSecOps, right? I mean, the idea behind DevOps, right, is that you have people who are operating the platform, and they kind of give you an environment in which to live as a developer, as an application creator. And you can roll security into that too by saying, as you said, right, it's like you can't use anything below port 1024, or you know. Other of those kinds of things, or even the read-only file system. But the other thought I had, which was kind of interesting, is one of the things that when I teach students about containers, is that they have trouble wrapping their head around is kind of the ephemeral nature of everything that's going on in it.
Right.
So I kind of wonder if maybe what I start doing is actually having them always use read-only file systems, like kind of from the get-go,
right.
because then they kind of like they start getting errors, right, that tell them, oh no, you need to make this thing that you care about not ephemeral, right?
Yep.
Which is kind of not how, like I said, they just kind of see it as they don't really even understand a process particularly well, and so understanding that it's this weird black boxed process is
Yep.
even more complex.
I mean, that's why things like Docker diff exist, right? To show you the difference between a running container and the original container image, what's been written. Lots of people do it. Lots of stuff that comes with your container kind of expects a writable file system. But you hit on a really good point there. You know, when when we have a security control like that, let's take the read-only file system. I could force that on the containers, right, at the cluster level, right? I suppose I could inject some control or modify it, but it breaks everything, and you get errors.
Right,
And
right,
what the developers expected. And that's a pretty common theme in security, right? Security puts a rule in place, blocks some network activity or something, and suddenly applications are down. And that's why the shift left, the DevSecOps model is go and change that in the code so that when you're building and testing locally on a workstation or in a dev cluster, that you can expect the same conditions when it get down the road into some production cluster, right? So the
right,
security is in the application, it's not in the cluster. It's not even in the security products, right? Security products are there to monitor what's going on. Just like any other observability, it's there to produce data for you to make decisions for the next build, for the next source code change. In
hmm
this model, change control for security is a pull request, right? I need a new
right,
firewall port opened. Okay, here's the PR for the network policy. It's reviewed, it's promoted, it gets into the automated pipeline. This is all, an ideal world, right? I mean, this is all
right, right,
the way we'd love to see everything work. It doesn't always work that way, but another thing is to remember is that security doesn't have to be perfect right away. It's okay to get better at security. We often find in my clients that Kubernetes development is well underway. Applications are already running in production, and there's not really been any of this security oversight. And suddenly, hey, we want to put this application out there live for production, or we need to get to something like PCI compliance for this application. And the security and compliance teams are like, well, where do we start? This is already all running. And it's tough to get to perfect right away. But it's okay if we start with oversight and we start with simple controls that improve security, right? There's no such
right.
thing as zero risk, but there is such a thing as lower risk, right?
Right, right. Yeah, I mean, when you talk about that, it brings to mind like, I pretty much use Podman exclusively over Docker, right?
Right.
And so by default, right, Podman does not run with root privileges.
That's right.
And I'm still amazed by the number of, kind of on the internet containers that I would like to use that won't run because they don't have root access. And I'm like,
Yep.
what is it you are doing that you need root on my machine in order to run your container?
That's right.
um, it drives me kind of crazy. But at the same time, so what I will do for some of those, to kind of your other point, which is like, especially if it's like a compose scenario, like where I have multiple containers that want to interact with each other, is I will then, okay, well, that means that this piece of software needs its own VM. And so I go build a VM and then I run the containers there with root privilege. And then,
That's
and
right.
so now if they compromise something because they have stupid amounts of privilege, they can compromise my VM, which is going to be pretty secure. And then eventually I'll get to the point where I go fix their code such that it doesn't require root. But I can start the path, right, without a huge amount of lift.
That's right. Yeah, I mean, every little bit helps, right? And so even low risk things that can be addressed easily. I think there's great opportunity here for developers to learn about this, right? Maybe they don't know that when I start a pod in Kubernetes, I've written a simple deployment, I get a whole bunch of privileges by default that most teams even know about, right? I get a service account token, from Kubernetes itself. I have writable file systems. I have, potentially I'm running as root inside of the container. I have a bunch of kernel capabilities. There's a whole bunch of things that are part of it that you're likely not even using. And so when you find out about things like the security context within the container spec in your deployments, there's all kinds of stuff that you can drop. There are simple things you can do. One of the others is, again, a simple thing the developers can do is stop using such big container images, right? You don't need a full Linux file system with every utility on it. There's a lot of makers out there of minimal container images. If you're using a compiled language, you could probably get away with even a scratch image. And
Mhm.
the bargain that I make with most development teams is like, look, in a mature organization, we're going to be vulnerability scanning your images, which means we're breaking them down, looking at all those components, right? You've got, all kinds of Unix utilities in there, and they're going to have vulnerabilities in them. And you're going to have to fix those. You're going to have to keep all that up to date. And that's not really your job. And you really don't want to do that. So using a minimal container image, guess what? I can make your job easier because none of that stuff is there. It doesn't need to be maintained. And you won't get in trouble for having a dozen critical vulnerabilities in your dependencies that you're not even using. So
Right.
there's a bargain there. Do a little bit more work, get used to the constraints of small container images, but the benefits are they're faster, they transfer quicker, they're more secure, right?
Well,
Um,
there's also the difference, which I think gets lost with things like containers or infrastructure in general, which is there's a difference between dev and production, right? Is like
that's right.
you can add all that stuff in to your container, wget and curl and I almost never use SSH, but ping and PS and all those things
Yeah,
while you're trying to make the thing go, right?
that's
And
right.
then you go back, right, and then you delete it all, so that when but you kind of, at least for me, I tend to start with something like Fedora Minimal, or I just blanked on the Red Hat equivalent. I want to
The
say OCI, but
UBI,
it's not it. UBI. Yeah, I
yeah,
was like, not OCI, not OCI,
yeah,
something else.
yeah, universal
Um,
base image, yeah,
yeah, so I tend to start with one of those things, but I still like when I'm doing kind of the development, when I'm doing the creation process, I have all kinds of stupid things installed, as well as I do like multi-line run statements. So like
right.
so even if I'm doing like DNF install ABCD, I'll do those multiple lines, because I want to take advantage of the caching while I'm doing development, right? And I'm like, oh, I forgot one. Let me go add that in, right? And then I go back and I make it all into one line with a clean
Right.
all at the end or whatever.
Yeah,
Because I think that's missing,
Mul- that's right. And these are tricks and things that it turns out have great deal of security value. Multi-stage builds are a really good
Yeah,
thing, right? Do your build in a context of a container that has all of the things that you need for all of that, and then copy the resulting artifacts into your production build, your final image container. Yeah, the topic of like curl in containers, is something that we call a component that's useful for an attacker, right? An attacker
mhm,
gains that foothold. We like to think of them installing malware in a sophisticated way. And a lot of them are doing, they're curling a crypto miner and they're going to execute that on your dime and hope you don't notice it. And so
right,
curl becomes a stage in an attack. It's not malware, but it can be used in a malicious way. And I know teams love to have curl in their containers. You exec in, you curl to test something, great. But it's one of those things that ends up being, just forward. You're supporting the goals of the attacker. We want to stop doing that. You use debug containers. That's a great way to do it. Create an image that has the utilities and you need it, and then you use the debug to attach that container to a running pod and go see what's going on. If you need something, if you find you're shelling into a container to find out what's going on, there's an opportunity for better observability. What is it you're not getting from your
right,
observability and your metrics that you are getting by shelling in, right? And a little bit more work, but it solves the problem and it's an improvement, going down the road rather than having folks get in there. If you can get in, then an attacker can get in. And so
right,
even things like it, I say most of my enterprise customers do not allow the developers or ops teams even to exec into pods in a production environment, right? Because it exposes potentially sensitive customer information to someone who may not need that. Or if they're going to do that, it has to be documented. There has to be an incident recorded. You need some paperwork to show that this was done for a specific reason, maybe to
mhm,
investigate a customer reported problem. But as long as you have some process around it. But I think that, the theme of the day is just this opportunity here. You're constraining the execution of your applications, and you can think about all the ways to do that. And you can really, really make these containers useless for anything
yep,
else other than the intended purpose. And I think that organizations that have a large number of applications on VMs, because of this, can get to better security. Your application is more secure in a Kubernetes cluster than it would be in, standalone on a VM in a Linux server. So
so I'll horrify you with but if I don't have curl, how do I do curl URL pipe sh to install my app in the container?
You mean pipe
You know,
sudo sh?
yeah, sudo sh. Yes, you got it right. But of
That's
course, I
my
have to install
favorite.
sudo most of the time. But
Right.
yeah, terrifies me. Um, the other one I was gonna, yeah, I really need to actually get better at. It's funny. I've been doing container stuff, using, kind of the Docker file for long enough now that when they introduce a material new feature like multi-stage builds, it's like I have to like retrain myself to stop doing it the way I've been doing it all the way along,
That's
and
right.
add that in because I really think they're really beneficial. But I just haven't been, I just have to like start using them every day. Otherwise, I'm not gonna, kind of adapt.
That's right.
But it's still a thing in progress for me. The other thing I was going to say too was, if you are, I don't know if you're familiar with the toolbox containers. So it was originally the Fedora toolbox, but now there's another one called DistroBox, which lets you use different distros as your toolbox. But I've been using those increasingly. I actually have a a distro box, but I have one for like one of my classes, and I have a different one for another of my classes, and I have a different one that is my kind of general working environment, which has, as you say, like all my tools installed.
Yep.
And if I wanted to, it could, I could deploy it into something like Kubernetes. Right now, that's, I just run it on my laptop as a way to kind of contain my tool chains. But yeah, those are super nice and super useful if
Yep.
nobody's checked them out.
Yep. Same here. I mean, I run a UBI based image, and if I need a utility, like I found I needed, TCP dump, right, to look at
Yeah,
network traffic, go into the Docker file, add that package in there if it's not already in the base, and then rebuild, and then just use that for that. That
yeah,
that kind of thing is something that it's a good process, right? Security teams like process, they like oversight, So if you're a developer saying, hey, this is how we're going to approach debugging something, we need an exception for this particular container to run it like this, like again, as long as it's documented, the process is there. Even very rigid security requirements like things like PCI or some of the federal government standards out there, they all have that kind of leeway for process and documented exceptions. So security doesn't have to be that rigid. We just kind of want the default, the everyday, the run of the mill to be tending towards more secure, right? Rather
well, and
than
I like
wide open
I
all the
like
time.
well, and with the containers, right? I also like that kind of accidental documentation. This actually happened to me like, a couple of weeks
Yeah.
ago, where I actually filed an RPM dependency bug because I was trying to run, and I can't remember what it was now, but I was trying to run something. I was running it in a container, and I did a normal install of it, and it was missing a library. And it's because that library is in Fedora main, right? And so they didn't have the dependency correct because it's always there, right? And so when I ran it in a container, it wasn't. So I think that's one of the things I really like about it is that exactly what you're using, and so then you can also pass it off to other people, right? I can say, okay, here's a container file that will launch this thing, and I know it works, because I can just give you the container file, which I
Yeah.
think is huge.
Absolutely. I mean, for reporting a bug, for reporting, let's say there is something that you suspect is wrong with that library to the upstream community, being able to say, hey, here's a Docker image that's sitting on Docker Hub that illustrates the problem, right? That's a
Mhm.
reproducibility boon, where you can report
Right.
something to say, hey, seeing this, rather than writing out the steps to reproduce the problem. Like here's a runnable version of it right there,
Yes.
and
Right.
showing you, that test case isolated in a container is a perfect way to do it. I think as you get more and more familiar with it, you come to love it. You come to love the advantages and the limitations, right? Like the storage one, it takes a while for people to get their head around. I encourage people to look at things like empty DIRs, right? Mount a temporary file system on your container and just, use what you have there. But as more and more applications are going to containers, there's more and more need of this, this awareness of this opportunity. Right? So that's really what it is. It's an opportunity for your applications to be more resilient to any kind of attack, regardless of what
Mhm.
the form of that is. We know there are more coming. We know that there will be sophisticated attacks against open source communities like the XE, social engineering / poison contributor kind of thing.
Right.
We know there's going to be more run of the mill errors that lead to buffer overflows and remote code exploits and things like that. So thinking about those things when you're designing how your application gets rolled out is really important. It's fun. I mean, I think that
Yeah.
teams who know a lot about Kubernetes can learn about these capabilities here. Everything that we've talked about is part of the container world. It's part of Kubernetes. I haven't spoken about a single proprietary control that you would need commercial
Right,
software or a
right.
license to do anything. This is all just part of it. It can be kind of complex, and it can be a little bit difficult to work around some of the limitations, but it'll make you a better developer overall, right?
Right, right. So, kind of circling back to the name of the show, what do you see in kind of the next 6 months or year or whatever, that's kind of coming down the pipeline in the kind of Kubernetes world that you're kind of most excited about? Is there anything in particular that you're looking forward to getting shipped?
Wow. There's a few things going on. So one that is everywhere, I think, is supply chain security, right?
Mhm.
Being able to show that a container image was built and it was run, it was the same thing, it wasn't tampered with. Actually, a variety of other things. So if you look at the SigStore project, right, with signatures, ledger, the certificate authorities, right, I'd urge everybody to take a look at that. This is going to become important, as things like XZ become more prominent, right? We have to be able to know where all of our dependencies came from, how it was built in our environment. Did this come from us? If you're working in an organization that supplies software to other companies, other organizations, if you're a software development house that builds software for the federal government, for example, you're going to be required to supply some of this information. You're going to be required to supply dependency maps. Things are going to have to be signed. This is, something that will happen. That is becoming relatively mature. The cosign project is nice because it just makes use of the Docker OCI registry to store those signatures and public keys and things like that. The other one that I'm excited about is something that's existed in container world for a little bit. It's called checkpoint and restore in user space, CRY-U. This is something that is yet to be, well, it's kind of in alpha, I think, or maybe beta in Kubernetes itself, where I could trigger the container runtime to capture essentially the running state of a container. So the idea there is that the memory, a file system diff, and other attributes sufficient for me to be able to go and, let's say, run that in a debugger and find out what was going on. So being able to checkpoint a running container is a pretty powerful capability for, debugging and investigating issues, but I think also for security to understand if a breach occurred, what did the attacker do? What specifically were the steps? What was running that they were able to exploit? So this container checkpointing in Kubernetes clusters can be enabled through feature gates. I'm not sure where it stands today, if there's like a Kube API for it yet, but obviously as this story is maturing, this capability will be something that's available in Kubernetes across the board. So two
Yeah,
things.
that's cool. I'm going to drop a link to I think the CRY-U main page in the chat. But also, I want to mention that, speaking of SigStore, way back in episode 3 of this show, we interviewed. I just blanked on who did we interview? Let's see. Luke Heinz of
Okay, Luke, I
SigStore,
know Luke.
about SigStore.
Yeah.
So go back and watch episode 3 if you want to hear more about it. Yeah, it's getting increasingly interesting. Kind of the whole. This is the story I often bring up. Like my mother, who's been using TurboTax for eons and eons, who and actually had bought floppy disks of TurboTax way back in the day, but it actually shipped with a virus.
Hmm.
Like somebody had injected a virus into the production environment, and there is this secure supply chain problem is actually been around for a really long time.
For
And
sure.
what's interesting, right, is that if you look at kind of RPMs, right, or devs or whatever, part of what they do is solve secure supply chain, as much as they can. And so I think that's we know how to do this in kind of the Linux world, but there's certain classes of software, particularly application software or custom built application software, that just kind of ignores it for the vast majority of the time, and because it's so hard typically, and so I think SigStore and projects related to that, right, and the containers, right, because now we're shoving it all in a container. In some ways, it actually makes it easier to have a good idea of what exactly is in there, for the same reasons that, I can find a bug in RPM packaging. You know exactly what is getting built in a container because you have to declare it all, which
That's
is
right.
huge.
That's right. The declarative nature of this is a huge key to why Kubernetes and containers are such a good thing for DevSecOps. You point out too that quite a while ago, Sigstore has been around for a long time. What's happening is the large scale adoption of these things, right? The requirements coming down either from public incidents that are spurring this, or requirements from regulatory sources. So the customers that I work with, right, large enterprises, are seeing a requirement to get to the NIST, or what they call the SALSA, right, SLSA, right, the secure software development life cycles that they're now required to demonstrate those controls. And I think that's going to trickle down to everybody at some point, right, to show that
Right.
these builds were conducted in our environment to our standards, they met our policy at this time, and that that non-repudiation and non-tampering capability that Sigstore brings is important. So
Yeah, yeah, totally. Um, so we're almost at the top of the hour. Is there anything else you would like to share that we didn't really cover?
I mean, security, we could talk all day.
Yeah,
There's a lot
right.
of things about, assessing your own individual risk and your organization's risk about things. I would definitely take a look at, at some of the talks and some of the white papers and blogs on the stackrocks.io site, where we share some
Mhm.
of these techniques. We talked a little bit about things like read-only file systems, but there's also cool stuff like dropping capabilities and dropping surface account tokens, or stopping the auto mount of those surface account tokens. So if you're looking for tips and tricks on how to get more secure, just kind of out of the gate with containers, there's tons of good material online. And of course, I know the material that's on stackrocks.io, the community site for StackRocks. Come and join us. Obviously, we're looking for folks to contribute and participate in the StackRocks community there, and we'd be happy to have you.
Cool. Awesome. Well, thank you so much for being on the show. We really appreciate it. We also have some security stuff on the KBE example site. And, for all those viewers out there, also remember to check out episode 3 and let us know if you want to see Sigstore come back. Like I said, thanks so much for your time and safe travels, because I know you're on the road a lot. And
That's right.
good luck with Red Hat Summit. There's a bunch of stuff that I hear through the rumor mill, like the kind of areas in which they're getting, that they're announced, not exactly what they are, but I'm actually really, really sorry to be missing it this year. So hopefully it sounds like it'll be a good time.
Well, thank you very much for having me.
Yeah.